Hello everybody. So I'm going to talk about the trial solution method. And this one I'll just sort of outline some steps that you should sort of take for the trial solution method. Um, so what I want us to do, so like let's say we're given um, an example problem, okay? And I'm just trying to see how to describe this. Let's say we're given an example problem and okay, so here's what I'll do. I'll just use the example that I have right here. So let's say I'm given a problem that says this, okay? X dot plus x plus, or x dot plus x equals t squared, okay? And they give us the initial condition that x of 0 is equal to 1. Now first, what I'm gonna do is solve the homogeneous equation, okay? So step one, I'll write it here. Is the homogeneous equation or homogeneous solution? I solve homogeneous problem. And we represent that by saying x subscript h. This basically says, and we assume xh is equal to d to the, yes, d to the st. And I don't really like, I don't know where that came from. I mean, I sort of do know where it came from, but okay, well, let's continue. Now, if I were to solve this, right? So basically, what we do here, right? We would say that d to the e to the st rather, times how do I describe this? If you can sort of try and break this down, that this would be equal to s and this would be equal to 1. Likewise, if I had an x double dot here, this would be s squared, okay? So once you see these dots, just know that that's like the power sort of that the s is going to. So we end up getting d to the st. So basically, the homogeneous solution, we solve it as if this were equal to 0. So the homogeneous solution will look something like this. X dot plus x is equal to 0. We totally forget about the right side and we equate that whole thing to 0, okay? That's why we can now say, so once we solve this for this, right, we sort of try and solve this and we end up getting d to the st s plus 1 is equal to 0, okay? And basically, this right here is what we call our characteristic equation. I can basically divide both sides by d to the de to the st, right? And obviously when you divide 0 by something, it becomes 0, right? So my s plus 1 is now equal to 0, and this is what I can call my characteristic equation, okay? And you can sort of do this in your head at a point in time. You can sort of just see it, but like I want to like do it step by step, because this is the first video. Characteristic equation. Okay? Now, you solve. Obviously, s is equal to -1, and that's one of our solutions, right? So now the solution becomes, so xh now becomes c1 sorry, I'm thinking e. So like, this is d, okay. E to the negative, whatever we have here. So this is e to the st, right? And I just wrote c1, you could have written d1. This is just a constant, basically, is what we're saying. So s, our s is -1. So c1 e to the -t. That's our homogeneous solution, okay? That's what we get if we were to set this equal to, okay, so like, I mean, I should probably just write d here, honestly, just so I don't confuse you. So like, I'll just say d, like, because we assume that this is the homogeneous solution, okay? And then our s we found to be -1. That's how we got this, okay? Then after that, we solve for the particular solution. So step 2, solve for Is this particular solution? Okay, yeah. Solve for particular solution. I guess like because I wrote particular homogeneous problem here, but it doesn't really. So long as you know what I'm talking about. That's what we call XP. Okay. Now there's a little table that you're gonna sort of have to know. So like if the right hand side. So this is what we're looking for now. Now we don't take this whole thing to be equal to 0. We look at the right hand side and we try and mimic this on the left hand side. What do I mean by that? If the right hand side consists, so the right hand side can consist of a few things. Polynomial, I think sine, yes? So when you say nth degree polynomial, right? Sine A of t, cosine A of t, and I think it was e to the a of t. Okay? And you can sort of like, there's sort of common sense like that goes on here. Not really common sense, but like basically, what we end up getting, right? We end up using this to mimic this, okay? So that ends up giving us okay, let me write it like this. If that makes sense, okay? So just depending on the polynomial I have, this is a second degree polynomial, so I'm sure you can sort of figure out what we're gonna do with this. Now this right here becomes the sine of a, sine a of t plus cosine a of t. Okay, and we have to include those constants, that's true. So I have a1 plus a2. And the good part about this, that makes it sort of easy to remember, is the same thing. And I guess you could say a1 cosine, since cosine comes first, but it doesn't really matter. And then this is just e to the a of t. And these are just constants, okay? That's just basically what's being implied here. So what we need to try and do now is sort of mimic this equation using this that we get from this. So what would our right-hand side look like? Our right-hand side would look something like this. Because it's a second degree polynomial, I'm just gonna stop after this point, right? So my right-hand side is gonna look like and I'm just using a different variable than this, just so we don't confuse ourselves, right? Okay, so that's my xp, okay? And because I'm trying to mimic this, I need an xp dot, okay? If I had an xp double dot, I would also try and solve for that, okay? When I solve for the xp dot, it gives me this as a constant when we're differentiating with respect to t, okay? This goes to 0. This is just a constant, right? This becomes a1 because we get rid of that t, and then this becomes 2 times a2 t, right? That's our xp dot. Now I'm gonna rewrite this as this, okay? So xp dot is equal to a1 plus 2a2t plus x dot, which is, plus x, which is just gonna be our xp. a0 plus a1t plus a2t squared. Now what we can sort of do, man, I really don't like working with these variables. Let me think. I can group like my t's together. I can group my things together. So once I group this, I get a1 plus a2t. And let me do this actually. I can do man, I'm trying to Okay, so like this whole thing is gonna end up being equal to t squared, basically, right? And how will I sort of portray this? Okay, so like, even like ignoring what I just did there, okay, we equate that whole thing to t squared, and what we can sort of do is like, we can sort of like look at like the specific, okay, so like this A1 and A0 are constants, right? This has a t at the end. Let me say this. This has a t at the end, okay? This has a t squared at the end. This has a t at the end. These are just constants, so I'll just write const. Cool. This is t squared, right? Now looking at the right hand side, right, I can sort of match up what we have. The constants, right? So I know, like, I'm just gonna bring this over here. How many more steps do I have? Just running out of space. Okay, so I know that A1 plus A0 equals 0, right? Because I'm trying to solve for these constants to get my full solution. I know that looking at this t, 2A2 plus A1 equals 0. And why do I know that these equal 0? I'm looking for all of the constants on this side. I'm looking for everything that ends in a t on this side, and there's nothing that ends in a t on that side there. But I know here that A2 equals 1, right? Because A2 is the only thing with a t squared. So now I can come back in and solve for this. If this equals 1, right? A2 equals 1. I know that A1 is going to equal, let me just do the math in my head really quick. A1 is going to equal -2, right? And let me just double check myself. Okay? And then if A1 equals -2, A0 equals 2, right? Yes. Now I can sort of rewrite this whole thing with this, right? So make my xp becomes I'm gonna sub all of these in here, okay? Let me just think really quick. My xp becomes, we want to sort of rewrite everything we just wrote in, but like, I'll explain this. Okay, so like using this right here, we're gonna sort of rewrite that, and I'm trying to think about how to explain that. In fact, like, just know that this is your XP, okay? It's sort of, I don't know, like, you have to sort of like try and make logic out of it, but this is like our XP, and we come back to this to get our whole XP, right? Because we had to use this and this to write this out and equate that to this to get our final XP, which is gonna end up being this, because our XP is A0, so it's 2t plus A1, so minus 2, I'm sorry, it's 2 minus, because this has no t, I thought that was a t. This is just 2, because this, I'm getting this 2 from here. A1 is -2 minus 2t plus A2 is 1, so I'm just gonna write t squared. And that's our XP, and let me just double check myself, okay? So now we go to step 3. Step 3, probably should have done step 2 down here, but that's fine. Step 3, we get our total solution. And this can be found by saying that x is equal to xh plus xp. This is the total x that we're looking for, right? So I just add this x that I found, this x to this. So you literally just add it. So xp, our total xp becomes our total x becomes d times e to the -t plus 2 minus, we're literally just adding that whole thing and tacking it on to the end. okay, plus t squared. But remember they gave us an initial condition. So they said that x of 0 equals 1. And this just basically means if I sub in t to be 0, my x is going to end up being 1. So let's go ahead and do that. And I'm just going to, just to conserve space, I'm just going to go through it with you out loud. So anything, e times anything to the 0 is just 1, right? So, okay, first of all, let me say this. So I'm going to, okay, let me just write it out. 1 equals d times e to the negative 0 plus 2 minus 2 times 0 plus 0 squared. Okay, this obviously goes to 0. This whole term obviously goes to 0. So I get this right here because I'm trying to solve for d basically. So this goes to 1 because e to the 0 is 1, right? So I get that d plus 2 equals 1. So I know that d has to be equal to negative 1. Okay? So that being said, I can say that my whole solution now is negative e to the negative t plus 2 minus 2t plus t squared. Because we've gotten rid of all of our unknowns. Basically, this was trying to get rid of any unknowns that we had. This was trying to get, okay, so we ended up with an unknown here, right? We ended up getting rid of our unknowns here, right? We ended up with unknowns, but we got rid of them, sort of figured out what they were, right? So after that, we added them both together and found that we had, you have one unknown, one equation, right? So you just solve for your unknown. So you just follow these steps and that'll give you your solution every time. Let me just make sure, yes. So that's what we have. This is the correct answer. So first solve for your homogeneous equation, your homogeneous solution, right? Or solve for the homogeneous problem, right? You assume that xh is equal to d e to the st, okay? And this, if you have more than one, we were lucky we ended up with one one solution here, right? But this could have been more than one. This could have been, if I found that my s was equal, s would have been valid for negative 1 and 2. I would have had d1 and d2, then I would have had to solve for both of those, right? After you solve for your homogeneous problem, you solve for the particular solution, right? We found that our particular solution ended up being this. You have to bring in your xp, you take the right side, you use this table to model this based on what they gave you on the right side, and then you plug it back into one big equation, right? And equate that to what you had on the right side, right? You solve for all of your unknowns and get a final particular solution, okay? You now combine those two to get a total solution, which is equal to the xh plus the xp that we just calculated there, right? Once you do that, you'll be able to solve for your unknowns, which I just wrote as d, and then you end up with your final answer, and that's what you do to get your solutions. That's really all you need to do. This is called the trial solution method. So there are different ways to like solve, and this is just one of them. Trial solution method, and that's what you end up getting. So if anything was unclear, please ask in the comment section. I'll do my best to sort of convey that. Please tell your friends to like and subscribe. You please like and subscribe also, and let's keep learning systems and vibes, systems and vibrations. Okay, thank you.